Polynomials-QOTD explaining photopure mathematics for A-levels. And today we're going to talk about chapter 3. Because I feel like chapter 3 is kind of easy chapter, we're just talking about polynomials and vietas. I'm going to make it into one lesson, and I'll try to be as elaborated as I can, and let's start. So, first of all, the entire chapter is about polynomials, as I have mentioned. So polynomial, a good example would be, as the textbook has given, 4x3 plus x squared take away 4x take away 1. That is a polynomial because we're expressing in terms of x. And generally we give it as a fx if we're drawing it on a graph. And we have the fx as the vertical plane. And the order or degree of the polynomial is the highest power of the variable in the polynomial. And a variable is one that varies based on the change in fx generally. And we wouldn't really have a repeating x value for different outputs if it is a polynomial or a function. And so in this case, the highest power is 3, which means it is a cubic. And then before that is a quadratic. And then after that, we generally just put it in terms of numbers, which is polynomial in the order n, or in the order 4 if it's higher than 3. And we often represent polynomial using a Cartesian plane with a graph. And generally that's a linear and then a quadratic, or other way around, and then a cubic. And then later on it just gets a bit more confusing, but then generally that's 4 because at most 4, and then 5 is that, yeah, at most 5, 1, 2, 3, 4, 5. So this is the one of the general sketches of graphs, and they can look a lot different. For instance, a cubic can look like this, but also like this. So it really depends on what kind of graph you're drawing. And then normally we find the turning points of a graph, and then the way after that, so like we know how to generalize and sketch the graph. And when the polynomial output is equal to 0, which means the fx in this case is equals to 0, we generally give the x values a name, which they are called as roots of the polynomial, of course. And a statement we can obtain from polynomials is a polynomial equation of order n has at most n roots, real roots, that's important. And then so in this case, when I draw a cubic, that's at most 3. It cannot be more. When it goes down, that's going to be a order 4. And that's essentially what a polynomial is. And now we're going to go a bit into Vieta. So first of all, we're going to start with the quadratic one because it's the easiest. So we write a quadratic formula in terms of ax squared plus bx plus c equals to 0. And that will give us the roots of the first root and the second root with arithmetic properties of r1 plus r2. I generally write x1 and x2, but then it's replaceable, so depends on you. Negative b over a, and r1 multiplied by r2 equals to c over a. You can prove this using the standard formula of a quadratic equation, which is negative b plus minus your formula. And then now symmetric functions of the roots of a quadratic equation. So if a plus b, alpha plus beta, you write alpha like this, plus beta, are the roots of a quadratic equation, then functions such as f alpha beta equals to alpha plus beta, exactly. And then f function of alpha and beta equals to alpha squared plus beta squared, and function of alpha and beta equals to 1 over alpha plus 1 over beta. So these are called symmetric functions of the roots because when you interchange the roots, the result remains the same. Essentially just that. Very straightforward. And then after that we have a cubic equation. And cubics are more interesting because if you think about it, they are okay, I'm gonna write it in terms of x still. So ax3 plus bx squared plus cx plus d equals to 0 because we're finding the roots. Or in a factorized form of a multiplied by x take away alpha, x take away beta, and x take away gamma equals to 0. So this gives the identity of ax power 3 plus bx squared plus cx plus d is identical to a x take away alpha, x take away beta, x take away gamma with a bracket, and then yeah, they're equal. And then multiplying out the right hand side, which means just expand it. I'm not gonna do it here because I'm lazy, and it's gonna give us a sorry, x. I'm using x here, so x3 take away a multiplied by alpha plus beta plus gamma. I mean, you can use the Vieta for this, but then I'm just gonna expand it first for now. Plus a multiplied by alpha beta plus beta gamma plus gamma alpha. And try to notice a pattern when I'm writing this. Multiplied by x and then take away a multiplied by alpha beta gamma. So that's the expanded form, and they are equal. So comparing the coefficients of each of them, because we know these two are the same, so we can ignore these. So we know b is equals to negative a multiplied by a plus b plus gamma. So dividing both sides by a, we know that alpha plus beta plus gamma equals to negative b over a because we have a negative a. And then on the other hand, we can also do this for c, which gives us alpha beta plus beta gamma plus gamma alpha. Sorry, I'm writing alpha really horribly because I'm messing myself up. C over a, and d equals to, alpha beta gamma equals to negative a over d, because we're just dividing essentially both sides by a or negative a, depending on how much coefficient you're on. So we can obtain these three results. So your alpha, beta, gamma, and alpha, because they minus to get 0, we know that they're the three roots. So your first root, x1 plus x2 plus x3 equals to negative b over a, and then your first root multiplied by your second root, and then root multiplied by your third root, and then your second root multiplied by your third root. Sum gives you c over a, so essentially just pair them up by 2, and then since we have 3, we know that 3, 2, that's 3 times 2 over 2, essentially we just have 3. And then last one is x1, x2, x3 equals to negative b over a. So the notation for such can be the sum of x1, like 1 value of your root, is equals to negative b over a, for a as the first, and then b as the second, and c as the third, and then d as the fourth coefficient. And then the sum of the paired up multiplication of your roots is c over a. And then the last one, which is the trio sum of the multiplication of 3 different roots, gives you negative d over a. So essentially that's just how you prove Vieta's formula for a quadratic and cubic equations. And then lastly, I'm going to really explain how you use Vieta's formula now, because in Vieta's formula we have found out about such. And then I'm going to write you for the power 4 formula for the sum of the full product of its roots, which is just the sum of x1, x2, x3, x4, and it's gonna be e over a. So what do you notice? we notice that the base is always the coefficient of the highest value. And then B, C, D, E. Essentially, the more you have, the more you go down in your power, your x power, to receive the coefficient that we are dividing A with. Okay, we're dividing it with A4. And then you see that there is negative and negative. So this one, it actually depends, because the first term is always going to be okay, it depends. So it depends on how many roots there are. So if I have a quadratic formula, okay, so this is the way you remember it. For the highest power, which is the 1 plus 1 plus 1 plus 1, is always going to be negative. And then after that, it's going to be positive, it's going to be negative, positive. And then, so this is going to be negative 1 to the power of k for how many k's there are. But then you realize that in the end, it's always going to be negative because you have negative a over b. Sorry. And then, so that's it. So you expand it and then you find the roots. And then, so the sum of roots to be multiplied can be written as sigma, and then 1 smaller than equals to I1, smaller I2, smaller I3, and then smaller equals to IK, smaller equals to N. And then the multiplication sum of J from 1 to K for R and then IJ values is equals to negative 1 to the power of K, which is how many roots there are, and then multiplied by A and take away K, and then AN. So essentially this will reach a value of non-existence because we won't have any in the end, since we only have a coefficient. I hope you understand. So it will just be a to the power of negative k multiplied by negative 1 and all that. So hope you learned something. It's pretty confusing, but I hope you understand, because k is smaller equals to n, so that one is going to be approaching your 1, sorry. And then you multiply by that, and then your an, and then you just get the constant, not the constant, but then your very term last. Yeah. Hope you understand. If you don't, I'll probably make another video about this, because Vieta's formula is very, very confusing. You can do so much with Vieta's formula. You can do Vieta jumping, and then your descent, all with Vieta. And I might put that in my competitive videos. But Vieta formula is really important, just know that, and it will help you a lot in your future. Go read the book if you don't understand.